Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. Right, so in this video, we start with the chapter 10, the last chapter in our syllabus for this first semester, which is the application of differentiation. So basically, in this topic, we have two subtopics, right? So the first one is the extremum problem, and the second one would be the rate of change. But to be precise, actually for extremum problem, we can divide into two cases. The first one is related to the graph or the function, right? Graph or function, which is up to the third one. And optimum value here is basically we're dealing with the maximum and maximum, minimum, area, volume, okay. And then lastly would be the rate of change. So that's what we learn in the chapter 10. Right. So the first three concept here, as I said earlier, related to the graph or function, right? So there would be the find the critical point, find the relative extremum using first derivative test, and also relative extremum using the second derivative test. So we'll see what difference between B and C in how to find the extremum, either using first or find extremum using second derivative test. So what is the extremum? So extremum can be categorized into different meanings. The first one is the stationary number. Right. I'd like to stress out here, the stationary is not the stationary pen, pencil. That one is also a stationary. But here, in our cases, stationary means when the rate of change with respect to x is 0, which is in other words, dy dx equals to 0 lah. Okay. So dy dx equals to 0. So that's the cases when we have an extremum. Okay. And also extremum we consider is a critical number. Right. So critical number also can be when f prime equals to 0. And also there are cases where f prime does not exist. Also we call critical number. So that's the difference meaning lah between stationary and critical number. But basically we consider all cases are critical number lah, as same as stationary. Right, here's the graphical representation of a critical number. As I mentioned before, remember critical we have two cases. The first one is a stationary, also a stationary. That is this one. The second one also we call stationary. So critical consists of both stationary, where the second derivative equals to 0, the first derivative equals to 0, and also cases where the slightly sharp changing sharp gradient here, where dy dx does not exist. Okay, so this is the cases where does not exist. Also we consider as a critical number. Okay, so this is the graphical representation of a critical number. Usually I think the first cases where dy does not exist may be, okay, maybe such as we have a piecewise. As you can see, the first one is a straight line and suddenly it changed into a curve-like function, right? So maybe one of the cases where the x does not exist. Right. So now we look at the other definition, which is a critical point. So what is a critical number? The different terms between critical number, critical values, or a critical point. Right. As you can see here, the critical number represents the x value. Okay, x value. And critical value represent the y value. And lastly, the critical point represent both x and y value, which is in coordinate form, right? So that's the definition lah. So number represent x, value represent y, and point represent the coordinate xy. Right. So now we could look at example 1. So in example 1, so given function f x cubed minus 3x plus 2. So we differentiate to find first derivative f prime. So differentiate here, we'll get 3x squared minus 3. So we know at critical, that is f prime equals to 0. So you have to make sure write down this notation. There are marks for these steps. So with that, we can equate that 3x squared minus 3 equals to 0. Okay, so either you factorize 3 or you can rewrite like this also can. So we know at the end x squared equals to 1 and x will be plus minus 1. So we know it will be negative 1 and 1. So let's say the first one. So when x equals to negative 1, so we substitute into the calculator f negative 1. So f negative 1. So make it clear the negative sign there. Okay, so f negative 1. So substitute negative 1 cube minus 3x plus 2. Okay, so we know that it will be negative 1 plus 3 minus plus 2. Okay, so they will be 4, right? Okay, and then lastly, when x equals to 1, so f1, so 1 cube minus 3 times 1 plus 2. So here we got 0. So at the end, we can conclude that the critical points here is negative 1, 4, and 1, 0. Okay, so that's for the first equations. Right, so now for the next equation, we have x power of 4 minus 8x squared plus 1. So again, we differentiate here to get f prime. So differentiate here, we got 4x cubed. So minus 8 times 2, 16. So negative 16x. I think that's all. Okay, and then we know at critical, so f prime equals to 0, right? So 4x cubed minus 16x equals to 0. And then we know that we can factorize 4, right? So factorize 4x. So inside here we have x squared and minus 4 only, right? Okay. So from here we know that we can get inside here x plus 2, x minus 2, right? So from here we got 3 values. There is 0, negative 2, and positive 2. So we have 3 critical number here. So for each critical number, we find the value of y. So first, when x equals to 0, so substitute f0. So 0 minus 0 plus 1. So we got 1. And then second one, when x equals to negative 2, so f negative 2. So substitute negative 2 power of 4 minus 8 times negative 2 power of 2 plus 1. So you calculate that, then we eventually will get the answer is negative 15. And also when we substitute x equals to 2, so f2, so we got also 2 power of 4 minus 8 times 2 squared plus 1. I think the answer also same, that is negative 15. Okay, so from here we can conclude that the critical points are these 3 points lah, negative 2, negative 15, 0, 1 and 2, negative 15 are the critical points for question B. Right, so for this question, it seems that the power is 5 over 3 and 2 over 5. I think it's quite complicated and difficult if we want to show in the graph. So even though the answer is given, but I think we just skip. Okay, we just skip this example and move to the next question. Right, so now for question D, given function f x times x plus 1. So as you can see here, so we have two functions, that is x and also x plus 1. So in order to differentiate this one to get f prime, you have to use product rule. So in order to find product rule, you have to find out first u prime and v prime. So as you can see here, we already find out u prime and v prime. So after we've obtained u prime and v prime, then we apply the product rule to get f prime. So remember, uv prime plus vu prime. So that's what we get. And then after we apply the product rule, so remember we have to factorize. So as you can see here, we have similar terms here, that is set x plus 1 and also here set x plus 1. So the smallest one is set x plus 1 and also we have over 2 below here. So we factorize both of them, that is over 2 and also over set x plus 1. So with that, the first term we only got x, the rest already factor out. And then for second term, since we also have set x which is above, so factorize we got x plus 1 power of 1. And then also we have to put here 2. So with that, we factor out, and then we notice that, so inside here we can simplify. Okay, so we simplify, then we get 3x plus 2. So that's the answer for f prime. And then don't forget, in order to find the critical point, you have to equate with 0. So we equate with 0. Okay, as you can see, we equate f prime equals to 0. And then since we already factor out, so we each factor we equate with 0. So 1 over 2 times x plus 1 equals to 0, and also 3x plus 2 equals to 0. So look at the first term. So actually over here, we bring reciprocal or we bring to the numerator. So 2 times x plus 1 equals to 0. And then after we bring to 0 and also over there, so we got x plus 1 equals to 0. So at the end we got x equals to negative 1. And then for another value of x, very simple lah. Straightforward, we got negative 2 over 3. So after we obtain these critical numbers, then we find the value of y. So substitute this value into the original function f. So when x equals to negative 1, so f negative 1 equals to 0. And also when x equals to negative 2 over 3, so we find out that f of negative 2 over 3 is negative 2 sub 3 over 9. This one we just plug it into the calculator. So we just straight away get the answer just like that lah. So at the end we can conclude that the critical points are, so negative 1, 0 and also negative 2 over 3, negative 2 sub 3 over 9. Right. Next for question E. So we have a function given x squared over x squared minus 1. So with this kind of rational function here, if we want to differentiate, for sure we have to do quotient rule, right? But there are methods that we can use in order to avoid using quotient rule. What is it? That is by using long division. Yeah, seriously, we do long division because the degree or numerator and denominator is same. So as you can see there, after we do the long division, the quotient is 1 and also the remainder also 1. So we can rewrite our function to be 1 plus 1 over x squared minus 1. And then we know later that we have to differentiate to get f prime. So to make easier for us to differentiate, so we rewrite the second term and bring the power above. So it will be x squared minus 1 to the power of negative 1. Okay. Then we differentiate. So we got f prime equals to, so we know differentiate y constant 0. And then remember differentiate power first. So we bring negative 1, the original power, to the front. And then the power will be power of negative 2 because the degree will reduce by 1. And then don't forget, inside here, we need to differentiate this one. So differentiate this one, will get 2x. Okay. Then after that, we can simplify. So f prime would be 2x over x squared minus 1 power of 2. Then, after we got f prime, don't forget, in order to find the critical, so we have to equate with 0. Right? So after we equate with 0, and notice that we have numerator and denominator. So the denominator here, if we bring this one to the right hand side, it will be also 0, right? So we can simplify. So to x equals to 0 and of course x equals to 0. So after we got a value of x, then we find out value of f0. So substitute, it will be also 0. So that we can conclude that the critical point in this case is 0, 0. So now we'll look at the relative or local extrema. So what is the relative or local extrema? So the function is said to have a relative or local maximum is open interval. So let's say like this lah. So in this case, so the top here is the maximum, okay? So here the maximum. So if you check, if you want to buat sine table, so we have the positive gradient, negative gradient, and on the maximum itself will be 0 lah. Okay. And then for minimum, so this is minimum. So if you check the gradient, okay, so the gradient before that is positive and the gradient before that is negative. Okay, and the gradient after that is positive in the sign table. Okay, so this is further if we have more than one extremum. So as you can see from the first graph, we have maximum here and also here, and for minimum we have here the minimum and also here the minimum. Okay, so for the second graph, so the graph maybe the piecewise function, that's why we got this kind of graph. So remember, this also critical, right? Where remember the differential of critical, but never mind about that. So just to show that this is minimum, this is maximum. Okay, right. So we will learn how to find the extremum. There are two methods to find the extremum. The first one is by using first derivative. So if we say first derivative, usually we refers to table. Okay, we have to sketch table. So this is a possibility. Maybe we get maximum, maybe you get minimum, or maybe it's not a relative extremum if the sign is same. Okay, remember to find if the sign table for maximum, it should be positive and negative, right? Positive and negative. To be a minimum, it must be negative and positive. Okay, negative and positive. So if not extreme, maybe it's positive and positive, positive and positive. So in this case, for C is not extremum. Okay, extremum, it must be a change of sign from positive to negative or from negative to positive. So as we already discussed here before, this is for maximum, this is for minimum. So no need to discuss detail. Okay, this is what I explained before. Okay. Right, next for using second derivative test. Second derivative test means that we have to find the second derivative, f double prime. Okay. So using second derivative test, if the value is negative, that is less than 0, so it will be maximum. And if the value is positive, that is greater than 0, it will be minimum. So that's the conclusion using second derivative test. So maybe in certain cases, it will be much easier lah if we use second derivative test compared to first derivative table. However, if the second derivative is equals to 0, so the test fail. So in that case, it would be no extremum lah in this case. It can't be maximum or minimum. So it will be no extremum in that case. Okay, if equals to 0, it should be less or greater than 0. Okay, to be extremum. Now look at example 2 here. Find the relative extremum using the first and second derivative test. So for question A, given function x cubed minus 3x plus 2. Right, so using the first derivative test, right, I don't go to detail because it is actually the same function as the example 1. So we know when we differentiate, we get 3x squared minus 3. And also we know that in order at maximum and minimum, f prime equals to 0. So we equate this f prime equals to 0. And then remember, when we solve, we got x equals to plus minus 1. And remember also, after we got the value of x, then we substitute into the original function to get the value of y. So when x equals to negative 1, y equals to 4. And when x equals to 1, y equals to 0. Right? Then we go to first derivative table. Remember, as I mentioned before, for first derivative test actually is a table. So we sketch the table and put our value -1 and 1 over there. Okay, and then we can see that we have to put a test value, remember, for using sign table. So one value that less than -1, we choose -2. And then for value between -1 and 1, of course, it should be 0. And then for greater than 1, so we choose 2, right? And then for f prime sign, so we just sub this value and we can use your calculator. So remember to use the calculate function. So put the function 3x cubed minus 3 in your calculator, and then press the use calculate. So first insert value -2, and you notice that you will got the value of 9. So 9 is positive value, and then you calculate. So this time we put 0, so we got -3. So -3 is negative sign. And then lastly we calculate and put 2, so we got 2. So 2 is a positive sign. Oh, sorry, it's not 2, it's 9. So we got value 9. So 9 is actually a positive value. So from the positive negative value, and then we move to the increasing decreasing of below there. So we know for positive it is increasing, negative is decreasing, and then positive is increasing. So with that we know that if the shape like this, positive and then negative, so the conclusion would be maximum. And then from negative to positive, so we got a minimum here. Okay, so with that we can conclude that our minimum point is 1, 0, and maximum point is -1. For remember, we already find out the value of y over here, so we just plug in and put as a coordinate. Okay, right? So this is the first method that is using table. Okay, first derivative using table. So how about the second derivative using second derivative test? Right. So now for the same question, we are using the second derivative test. So the first step is same, right? We find first derivative and then equal to 0, find the value of x, and then we got value of y for each x that we got. And then since we're using second derivative test, okay, so we differentiate again to get the second derivative. So differentiate, we get 6x from 3x squared minus 3, we got 6x in second derivative. And then from the value of 1 and -1 over here, so we substitute into the second derivative. Okay, so first we substitute -1, so we got -6. So -6 is less than 0. So since less than 0, so the conclusion would be maximum. And then secondly, we substitute x with 1. So now with the value of is 6, so 6 is greater than 0, so 6 is greater, the conclusion would be maximum. So remember that highlighted here, you have to write in your conclusion less than 0, greater than 0, and put maximum minimum if you want to use second derivative test, in order to avoid losing any marks. Okay, then after that you put the final conclusion, that is the minimum point is 1, 0, and lastly the maximum point is -1, 4. Right, so now for question B, so given function f, x power of 4 minus 8x squared plus 1. So using first derivative test, Right, so we know that f prime is, we differentiate, so f prime would be 4x cubed minus 16x. And we know at maximum or minimum that f prime must equals to 0. So we equate the f prime with 0. And then we notice that we can factorize x and also 4. So factorize. So inside there we got x squared minus 4. And this x squared minus 4 can be further factorized to be x plus 2 and x minus 2. So with that, straight away we determine these three values. That is the critical values. That is x equals 0, negative 2, and 2. So with these three critical values, so we find the respective value of fx. That is the value of y. So when x equals to 0, so f0 equals to 1. So when x equals to negative 2, f negative 2 is negative 15. And for x equals 2, so f of 2 equals to negative 15. Okay. And then next, we sketch the table. Remember, for first derivative test, we have to sketch the table. So for the table, so we put the critical values there. That is negative 2, 0, and 2. And then at the rows, we have a test value, the f prime sign, and also for increasing, decreasing. And don't forget also the conclusion. Right, so first we put the test value. So for less than negative 2, so we suggest to put negative 3. Between negative 2 and 0, we put negative 1. Between 0 and 2, it is 1. And then for greater than 2, we suggest to put 3. And then for f prime sign, right. So here, I suggest you, so this is the f prime. So put this f prime into your calculator. Okay. So put in your calculator as a function. So use the calculator, right? And then we use the calculate function. So no calculate function. So we substitute this test value. So when x negative 3, so the sign will be negative. When x negative 1, the sign is positive. When x is 1, the sign is negative. And when x 3, the sign is positive. Okay, using calculator. So with that, we from negative positive here, so we can determine the increasing, decreasing. For negative, it will be decreasing, and for positive, it will be increasing. And we notice that they will alternate between decreasing, increasing, decreasing, and also increasing. So with the increasing, decreasing here, therefore we can determine which one is minimum and maximum. So decreasing and increasing, it will be minimum. Increasing, decreasing, it is maximum. And then decreasing, increasing, it is minimum. So after we determine which one minimum and which one is maximum, then we can conclude that the minimum point would be the point negative 2, negative 15, and also 2, negative 15. And then for maximum point, it is at point 0, 1. So this is using first derivative test. Right. So now for the same sum function, we are using second derivative test. So before that, as usual, we find the f prime and then we equate with 0, the f prime. So from there, we can factorize and obtain the critical values. And also remember, from these critical values, we find the respective value of fx. So later on, we will use this one to write the minimum or maximum point. So before we determine which one maximum minimum, so in this case we're using second derivative test. So we differentiate again to get the second derivative. So the second derivative will be 12x squared minus 16. And then look at that when we substitute the respective value. So when x equals to 0, we got negative 16. So negative 16 is less than 0. Remember, you must put less than 0 and put the conclusion here maximum. Okay. And then next, when x negative 2, so we got 32. So 32, make sure you put greater than 0 and then write the conclusion it is minimum. Then lastly, when x 2, so we got 32 also. So 32, so write down 32 is greater than 0 and we should conclude that it is minimum. So with that, after we identify which one maximum and minimum, then we can write down the conclusion here. The minimum point is negative 2, negative 15, and also 2, negative 15, where the maximum point would be 0, 1. Right, so that's all for this video regarding determine maximum minimum point using first derivative table or by using second derivative test. So for the next video, don't forget we will discuss about optimization. So optimization here, for example, let's say we want to find a maximum area, minimum volume, and so on. So this is regarding optimization. So stay tuned for that in the next video. Until then, bye bye.